In this tutorial, I will demonstrate how to use meshes, terrains, and materials within AnimatLab. We'll do this by building a little beach scene. For this simulation, I'm going to be downloading all of the meshes from the 3D Warehouse in Google SketchUp application. If you want to use meshes in your projects, then you really need to get SketchUp. It makes it very easy to create, edit, and export meshes for your simulations. And its warehouse has tons of free meshes available for download. However, if you want to use SketchUp meshes within AnimatLab, then you'll also need to download a plugin called SketchUp to OSG. If you go to www.github.com and then search for SketchUp to OSG, it should take you right to the link. And then a little bit further down, there's a downloads link. And then this will take you to where you can download an installer to install the plugin that you'll need. So what this plugin does is it allows you to export whatever meshes you download from the 3D Warehouse into a file format that can be read in by AnimatLab called an OSG. So I've already installed that, and once you install it, you get an export to open scene graph here, and then you can export an entire document or various selections as OSG objects that you can then read in AnimatLab. So let's go ahead and go back to AnimatLab and create a new project. We're going to call it Beach. So one of the first things we need to do is change the scaling units so they're appropriate for the environment that we want to simulate. So we're already on the environment node, so let's go ahead and click here on the units. We're going to change it to be meters and kilograms. And that causes us to reload the project. Once that's done, you can add a structure. You can either right click and say new structure, or you can come up here and click the new structure button. And we're going to call that beach. Then let's go ahead and add a root body. And we're going to select the plane part. Okay, and then let's double click on the body plane, and that will open up our viewer. You can see we've got a plane here. So let's go ahead and change it to be 40 meters. 40 meters. Okay, and now let's go to the internet and Google for sand texture. And that one looks pretty good. So save the image into our project directory. And then let's apply it to this plane. Okay. So what you can see though is that it stretched that one image across the entire thing. So what we want to do is to tile it so that it looks more realistic when you're closer up. So now we've done that. If we zoom in, now we can see that it looks like sand even as you're zoomed in. Now let's go ahead and get our first mesh and then use it within AnimatLab. So let's go back over to SketchUp. And now let's select the default person that's added and delete that because we don't want that in our scene that we're going to export. Then go to the 3D Warehouse and say Get Models. And then we're going to go with Bongo. And download it. Then we want to reposition it if we can so that it's at least to try and get it where it's on the axis. It'll make it easier to to deal with it within AnimatLab itself. Okay, kind of down through the middle there, which make it easy to position. Okay, so once you've done that and you've got it selected, first of all, let's go ahead and save out our SketchUp file so that we can use it when we need it. Create a new folder called Bongo. Okay. Now we're going to export it out to AnimatLab. So you can go ahead and take the default settings here, and we're going to save it as bongo.osg. And once it's done, it's going to open up a little viewer so you can see what it looks like. Okay, so once that's done, then we can come into AnimatLab and try and add it into our scene. So basically in this scene, what we're going to try and do is to have a palm tree with a coconut on it, and then have a bongo underneath it, and the coconut's going to fall, bounce off the bongo, and then kind of roll away. So there are several different ways to add meshes into your scene. I'll demonstrate those different ways today. The approach that you should use most of the time is to use a simple geometric shape for your physics, and then use the mesh only for the graphics so that it looks nice. The reason you want to do this is because using simple geometric shapes like a box, cylinder, and a sphere are much faster than using meshes for your physics. Notice that I did not include the cone part in that list. Internally, cones are implemented using a very simple mesh, so they don't buy you a whole lot speed-wise compared to the basic geometric shapes, but they are going to be faster than the larger meshes that you can pull in. So let's go ahead and add a cylinder to represent the dynamics of our bongo. You can do that by right-clicking on the root and saying Add Child Body, and selecting Cylinder. So we do want it to be a collision object, but we don't want it to have Add Default Graphics. The reason why is because we're going to be adding our own graphics mesh for it later on. So go ahead and click OK. Then it'll ask you for the joint type you want. So we're going to use a free joint, and basically a free joint is no joint at all, so the different parts can move completely independent of one another. It's just the contact collisions that constrain them. Okay, so it creates a big old cylinder for us. Let's go ahead and name it Bongo. Let's change the height 0.35 and 0.1. Move it up a little bit so we can see it. And let's change that to the density to 30 kilograms per cubic meter, so we get a mass of 0.33 kilograms for it. Okay, so once we've got that and we've got our cylinder basically how we want it, let's go ahead and do Add Child Body again. This time we're going to click on Mesh, and this time though, instead of collision object, we're going to have graphics object. So graphics object, unlike the collision object, it has no dynamics. It's just there purely decorative, that it looks nice for your scene. It will follow along with whatever collision object is attached to, which in this case is the bongo, but things can pass right through it, and it doesn't affect the mass, density, forces, anything like that within the scene. And once you add that, then it's going to bring up a dialog box that's going to ask you the location of the mesh file that you want to load into it. So we're going to go ahead and click that, and let's go into the bongo, and here's the bongo OSG file that we exported out of SketchUp. So go ahead and point it to that, and hit OK, and then you can see our bongo is loaded into our scene and is visible now, but it's rotated a little bit. So we want to rotate 90 degrees along the x-axis, which is the red, y is in green, and z is in blue. and it's in that orientation because this axis is showing the relative orientation of our bongo part relative to its parent, which is this dynamic cylinder. So we want to go 90 degrees in X. Okay. Our bongo is actually a little bigger than what our cylinder is. So let's go ahead and do some resizing on it. So regardless of whatever size you save a mesh out as, you can always rescale that within AnimatLab to meet whatever needs you want. And this works with both collision and graphical meshes, so that you can change their sizes. So let's go ahead and change this to 0.5 in each dimension. Okay, and I'm going to focus on the bongo to make things easier for me. Okay, now let's reposition the bongo a little bit to try and center it up there. Actually, it looks fairly centered that way. Okay. Okay. So now we have this cylinder, which represents our dynamics, and then we have the bongo, which will be what you'll see within the simulation itself. So if we go ahead and run this real fast, well, all we're really seeing right now is the collision object, which is encompassing that. So let's go ahead and fix that. Go here to the transparencies, and within the simulation we want this collision object to be 100% transparent when the simulation is run. Okay. So we do still have this joint here that's not transparent. So let's get rid of that as well. And let's move it out of the way so it's really visible at all. Okay. There we go. Now we have our bongo. Let's move it just a little bit. Oh, move it a little bit down. So one thing to note about this is if you try and move the graphics mesh, it's going to be moving it relative to its parent. So you can't really move the whole thing. If you want to move the bongo as a piece, you need to move the collision object part, and that will move your graphics along with it. So let's put it right near the bottom of the ground so it's sitting on the surface. Close enough. Okay. Oh, actually, one last thing before we move on. Let's go ahead and rename this to be bongo graphics. Now that we have our bongo, we're going to add some of the other items to the scene. So I'm not going to go through the whole steps of finding, downloading, and converting each of the meshes from this point on because it's all done exactly the same way we did with the bongo. If you want the meshes I use for this project, then you can download this simulation from the Animat Warehouse and use them from there. So I've already downloaded the meshes that I'm going to need, and I'll just import them from this point on. So I'm going to copy these over into the beach scene so that we can use them. Okay, so now the next thing we're going to do is to add a palm tree. So again, add a child body to that. We're going to use a cylinder. I'm not going to use a graphics mesh on it. And we're going to have a free join again. Let's change the name to tree. We're going to change the height to 5 meters. And the radius to 0.1 meters. Let's move it off just a little bit. Change the dragger size so we can get to it. Not too much. There we go. Okay. Now let's freeze this because the tree's not going to be moving in our scene. Next, let's add the tree graphics. Let's go ahead and add a child body. Select the mesh, and this again is going to be a graphics object. And we're going to use the coconut tree mesh. Let's go ahead and scale it down to 0.5 each dimension. Okay, and let's change the dragger size so that we can actually grab hold of it. It's got to be able to stick above the tree. There we go. Now kind of move it down. Okay, that lines up pretty well. Okay. Okay, we're going to set the transparency for the tree collision object to 100% so we can't see it within the simulation. Okay, let's go ahead and run our simulation real fast. Okay, we got it. One thing you might notice that time is going by at an amazing pace here. Basically, we don't really have anything going on in our simulation, so it can go really pretty fast. Let's go ahead and change that for our simulation. So it's set now to be fast as possible. Let's go ahead and match the physics step. Let's run it again. So you can see a more reasonable time period that tries to match the real time. Okay. So now we have our tree and our bongo. Next thing we're going to do is add onto the tree, we're going to add a child part. This time we're going to add a sphere. We're not going to add any default graphics to it, but it is going to be a collision object. So basically what we're going to do this time is just use the collision objects graphics as our simulation graphics as well. No point having two different things in there if we don't really need it. Okay, we're going to use a free join again. And we get a great big huge sphere. Okay, let's call it coconut. We're going to set the radius to be 0.08 meters. Okay. And let's set the transparency for it in the simulation to be 0. It already is. Okay. Let's go ahead and focus onto the coconut so we can mess with it. And change its dragger size so we can get hold of it through the tree. Whoa, too big. Okay, that looks pretty good. So now let's change. Let's go ahead and change the color from red to white. Then let's go ahead and Google um, coconut texture. Save that out, and then apply it to our coconut ball. Okay, there we go. We have something that looks like a coconut now. We'll apply on our tree. Let's see if we can position our bongo to be kind of under it. Now let's run the simulation. Okay. Okay, so you can see that the coconut's falling, but it's not really acting really very realistic at this point because it's just hitting it and immediately stopping. That's because of the way the damping and stiffness of the various collisions are occurring. Thing too, we didn't actually set the mass of our coconut to be very high. Oops. There. So let's set it to be 1/2 kilogram. See what it does now. Yeah, boom. It kind of rolls off a little bit finally. And it just keeps on rolling. There are several unrealistic things about this simulation. The first is that once the coconut falls off and starts rolling, as you can see, it just keeps on going. It won't ever stop. There's no friction between it and the ground at this point. Even though we've set up friction for the ground in general, as you'll see, that doesn't apply to rolling friction. Rolling friction is something that you have to add in explicitly. Okay, the other unrealistic thing is, like I said, it hits the bongo, doesn't bounce at all. It just hits it and then kind of rolls a little bit and eventually rolls off. So that's fairly unrealistic too. We can fix all of these problems by using the material editor within AnimatLab. If you go up here, you can do Edit Materials. Okay. The material editor lets you create material types to be used by the parts within your simulation. This lets you control things like the stiffness and damping used when two parts collide, and the friction forces that they generate. Let's start by adding that bounce into the collision between these two parts. Let's go ahead and add a new material type and call it bongo. So add a material. Let's change the name to bongo. Okay. Let's change the compliance to be 0.1 millimeters per newton, and the damping to be 1 kilogram per second. So this compliance and damping parameter are basically whenever two parts collide, it's like very stiff springs are between them to stop them from interpenetrating. So as they try to force themselves together, the spring pushes them back apart, and the amount of damping and compliance determine how the spring behaves. So if it's very damp, it's gonna not bounce very much. But if it's less damped and it's still a fairly stiff spring, it'll bounce more. So basically, what we're doing is we're removing some of the damping and making it a little bit more compliant, so it's not quite as stiff. Otherwise, you could get instabilities. If you've got very stiff spring with no damping at all, you're going to get stuff that's pushing up really hard. So let's see what this one does. Okay, so this time it did nothing. You see, it did the exact same thing it did before. Why was that? Okay, if we go to our part, you can see that we did not actually tell the bongo to use that material type. It's still set to default. So that's an important thing you have to keep in mind, is that even though you set up your material types, you have to actually assign those materials to the part. So let's select bongo. Try this again. Whoa! Now it jumps up high. Actually, it's jumping up way too high. We can see both our coconut and our cylinder bongo are rolling away, and again, they're going to roll for forever. They've got no rolling friction on them right now. Okay, let's go ahead and open up the editor again. Let's go in here and make this a little less bouncy. Let's go back and adjust the compliance to set it to 0.5. So we're making it just a little bit more compliant. And the damping to 50. And we're increasing the damping a bit. Okay. Let's run this again. There we go. That's a bit more realistic. So it kind of bounces off it just a little bit and then kind of rolls away. Okay, now let's go ahead and try and fix some of the rolling problems. Let's go ahead and open the editor again. And we're going to go ahead and create a new material called coconut. Okay. And so one of the things you can see up here, there's a set of friction coefficients. There's linear primary and linear secondary. So this is your friction coefficients along the x and the z axis of movement, the coefficient that's applied for those. And you can see that right now we have some that's set to 1, but you can also see that these angular ones, which control spinning and rolling friction, are all set to 0. So basically, angular primary and angular secondary are for rolling motions along the x and the z axis. Angular normal is for spinning motion around the y-axis. So what we're going to do now is to try and add some rolling and spinning friction. So these are set to 0 by default, and one of the reasons is that this is not typically something that's needed for every single object. You would only really use this for things that can roll, which would be things like a cylinder, or sometimes a cone, or a sphere. And you'd want to turn this on a case-by-case basis because it's a little bit more expensive. So there was no, computational wise, there was no point in having it on for everything. Basically, you just want to turn it on for the parts that you really need it on. So create a new material type for that and assign it to be that, to have angular friction coefficients. Okay, we're going to set these initially to be 1 milli. So it's fairly low values. Okay, and then don't forget to go and change the material type for our coconut to use the coconut material. Okay, let's try and run it again. Okay, you see it this time it rolled for just a little bit and then quickly stopped. So this is much more realistic behavior for how a rolling object would behave in sand. We can adjust this too. If we go back to the material editor, we can change the angular friction again and cut it in half. This time you see it roll a bit further. Okay, let's finally go back to our bongo and add just a little bit of angular friction for it as well, because if it falls over at some point and starts rolling, it would also just keep rolling unless we had some angular friction as well. Let's run this again. Okay, so let's try this real fast. Might have to change your mouse spring stiffness. Let's try 5. And using the Control Shift keys, that's still not enough. 10. There we go. And you can see that now it stops, whereas before it would have just kept on going. There we go. So before I move on, I'd like to quickly go over the other material type settings so that you can have an idea of what they do. Let's go ahead and open the editor again and click on one of these. So we've already gone over the coefficients and the compliance and the damping. Next up is maximum adhesion. So if you set a maximum adhesion, then basically when parts collide, it's like they're stuck together with glue or a sticky tape or something, and you have to apply more than the maximum adhesion to be able to break them apart. So this lets you have collisions of things that come together. Restitution is a fractional value representing the ratio of speeds after and before an impact. Finally, there are a few sections where you can set a value for each axis where you can apply friction. The first section is the maximum friction force that can be applied. This value sets a limit on the amount of friction force that any of the friction equations are allowed to apply along that given axis. The next section is for setting a slide value. By default, friction tries to set the relative velocity at the contact point to 0. Contact sliding enables you to specify a desired relative velocity between the colliding parts at the contact position. An example of such an application is a conveyor belt, where the belt part itself would not be moving. The final section is for slip. Contact slip allows you to define a tangential loss at the contact position. For example, this is a useful parameter to set for the interaction between a cylindrical wheel and a train, where, if it doesn't have a minimum amount of slip, the vehicle would have a very hard time turning. One last thing I'd like to mention about material types is how they actually work together. So when two parts collide, they can have different material types with different friction coefficients, damping, compliance, and so on. When this happens, the physics engine merges the two material types to find a contact material that uses the most compliant settings between those two types. So in other words, it would take the lower of the two friction coefficients or dampings and use that to control the interaction between the two parts. So you need to keep this in mind when you're setting up your different different material types for each of your objects, in thinking about how they're going to interact with each other. So if you have ice and concrete material types and you put the ice on the concrete, then it's going to be using the ice settings because it will be the more compliant generally, have lower coefficient friction and so on. So now that we've seen how to use graphics meshes and learned a little about material and friction types, I'd like to talk some about collision meshes. So let's go ahead and add a surfboard to our scene. I downloaded a surfboard from SketchUp and exported it. So go ahead and right click on the sand and add it as a child part. So this time we're going to keep collision object, and we're also going to keep add default graphics. Okay, we're going to use the free join again. So as soon as you do that, again, like before, it comes up asking you where the mesh, for the location of the mesh file, but this time it also has a mesh type, because this is for setting the collision object. So you have two options, convex and triangular. First we're going to look at convex. So basically the difference between these is that for a convex, it can't have any concavities within it. So it has to be a completely convex object like a sphere or an oblong or that type of thing. But the good thing is that you don't have to necessarily make that yourself. What you can do is just specify the mesh itself, and this runs it through a preprocessor stage that goes over the mesh and computes a new minimized convex mesh and saves out a new mesh file for you within your project folder that is used for the collision object itself. So essentially you don't have to even create the convex mesh in order to be able to use it. So let's go to surfboard. Okay. We're going to go convex. So next it comes up and asks you for the graphics mesh, and it assumes that you're going to use the one that you just selected as your graphics mesh. You can change this here if you want, but we're just going to go with the default. Okay, and so it added it to our scene. Let's go ahead and position it a little bit. Okay. So we have our surfboard in there, and here's kind of what I meant by a convex mesh. So you can see the board has this base part, and then it has these fins that come out. And you can see that there's a kind of an envelope surrounding it now, the board. This is the convex mesh. So you can see how it kind of wraps around the various parts. And if we come in here now and look, we have a surfboard and a surfboard underscore convex. This underscore convex was created by us by the application automatically, and is this one that wraps around it here. So that's the minimized convex shape that was created when we loaded up our mesh. Let's go ahead and rename these. Okay. And now let's go ahead and well, actually, let's move it over just a little bit. And then let's run the simulation and see what happens. So it actually looks like it behaves correctly in that the surfboard falls and it rests on the fins and the front of the board. So it looks right. However, one problem is that the mass is not going to be distributed the exact same way as it would in the real surfboard. Because as you can see, there's a lot of space here where there's going to be mass that's going to change how this behaves. For instance, if you were trying to float it in the water or that type of stuff, or if you were trying to apply forces to it, it's not going to react in exactly the same way that the real surfboard would, because of the different ways that the mass is distributed here. In some cases, this may not be a problem at all. For instance, if we were just wanting to see it falling over like that, or doing something, resting up against something where things could hit it, but we don't really care about how the physics of the surfboard itself works, then it's not really a problem, and you can just go with this. However, in some cases, if you really did care about the exact physics of this surfboard, then this probably wouldn't be good enough for you, because of the way the mass is distributed differently than in the real system. An example of that is the locust jumping simulation. If we had something like this, well, actually, let's just show you real fast. So let's quickly add a child body. We're going to add a mesh, add a graphics mesh. We're going to use convex, and we actually have the thorax here. This is from the locust simulation that you can download from the warehouse. Okay, and it comes in really huge compared to the. This is just a matter of how the mesh was saved out. Let's go ahead and scale it down to make it. Okay, so this actually kind of demonstrated a couple things here. We loaded in a convex, we loaded in our locus thorax mesh as a convex mesh, so it generated the envelope I was talking about before. We were able to scale it down. So you can scale both collision and graphics objects, and it will change the volume and the mass of that part for collision objects when you scale it. So that's done correctly. So one thing we see here, though, since we did a convex mesh and had these antennas, it tried to create an envelope around this. Now, with the physics of the locust, it's important because we're trying to do jumping, and this is going to redistribute the mass far forward of where the head actually was, and that would make it incorrect. So we'll talk a little bit about ways you can solve this here in a second, but this is just something to keep in mind if you use a convex mesh, that you've got to think about this. You can't just use it by default, but at the same time, you want to use the simplest thing you can. If you've got to use a mesh, convex mesh is better. But we'll talk about some possible ways of dealing with that. So if we were to run the simulation, you see it kind of flopping over. And one thing you can do too is, if you'd like to see actually the collision mesh within the simulation itself, I mean, you can turn these on for any of the. Basically, you have complete control of the transparency of any of the objects within the system. That means the graphics objects, collision objects, joints, all of it. So let's say in the simulation I want this to be 50, just like in here. So now you can see the collision objects. You can actually see, you can grab hold of this where there's no actual graphics mesh and kind of move it around. There are two basic ways that you can try and get around this problem. The first would be to use just a triangular mesh. One issue with that, there are two main issues. One, triangular meshes are going to be much slower than even a convex mesh, because basically the convex mesh is the physics engine can simplify the equations it needs to use to calculate things with a convex mesh, because it can assume that there are no concavities. The other is that the convex mesh is actually a minimized mesh. So if you look, especially like this one, it's tried to create the minimal number of polygons needed for this convex mesh. So it's much simpler than just the regular mesh itself, especially like for the locust one here. But it has a lot of polygons. So if you're doing triangular mesh with that, it's going to be slower. The other problem, though, is a little bit more extreme in that some triangular meshes seem to work fine, and some of them don't work at all. And this is kind of a crapshoot, especially for ones that you just download off the net. And basically, the main problem, I think, is that the way the meshes are created and defined. I believe if there are any holes whatsoever in the mesh, that the physics engine can't calculate the volume correctly, so it can't calculate the mass, and that is a real problem with any collisions. So for instance, let's take for example, let's go ahead and add this let's go ahead and add this locust back in, but we're going to do it as a triangular mesh this time. Scale it down a little bit. Okay, now if we run that one, so the triangular mesh works fine on this one. It can run. However, let's try it the same thing with the surfboard we just had and see what happens. We're going to use triangular mesh this time. Okay, this time you can see that it did not create that same envelope around the mesh itself. We have the fins that are still sticking out and so on. So let's just go ahead and see what happens when we run this one. Yep, and you see it. Things slowed down in the simulation. It came to a screeching stop, and we had something. The surfboard just disappeared. So again, sometimes the triangular meshes will work, sometimes they won't. This is just another good reason to avoid triangular meshes at all possible if you can, because they're difficult to use and they're really slow within the simulations. Okay, we'll get rid of all those. Okay, so if that's the case, so if you can't use triangular meshes, and sometimes you're going to have to. If your triangular mesh doesn't work, then you're probably going to have to try and optimize the mesh and play with it to get it where it actually works correctly and doesn't have any holes within the mesh itself. All the vertices are connected together precisely. That can be a big job. A much simpler way of approaching it is to try and decompose your mesh into convex parts. So in other words, with this surfboard we have the main body part, which is convex, and then we have a fin part, which is convex. So if we were to save those out separately, then we could use two convex parts which would have the same mass distribution as the regular part. So let's go ahead and get SketchUp up and running again. Let's get rid of our well, actually we're going to load in our surfboard. So this is the one we created earlier. So we're going to, whoops. Okay. So basically, let's start by creating the fin. So we've got this main surfboard part there, and we just delete it. Okay. Delete that fin, and delete that fin, and that leaves us with one single fin. So let's go ahead and export that guy. And I've already done this, but I'll do it again. Okay, so that exported the fin. Now let's reopen our base surfboard. And you want to make sure if you're doing this that you've got something to fall back on, which has the whole part. Now we want to let's get rid of each of the fins. Okay, so now we have just the base. Let's go ahead and export that. Okay, now we can go back into AnimatLab and let's add a mesh with graphics, free joint. We're going to choose the surfboard body. and we're going to have convex. Okay, so this time we have just the body with no fins on it. Okay, now what we're going to do, let's go ahead and change this name. No. Okay. So now click on the collision portion. We're going to add a child body. Add graphics. And this time, instead of free joint though, we want a static joint. So a static joint links two collision objects so that they're basically one part. So there's no real joint between them. They are literally like they are welded together. Moving one of them moves the other, and there's no forces aren't going to be moving those, be able to pull those apart within the simulation. They're welded together. So this also is a convex. We want the surfboard and we want the fin. Okay, so that creates one of the fins. Let's go ahead and name it fin 1. And actually, we don't even really need this graphics in this one. We can just use the collision part. Okay. Another one. Again, a static joint. And we're going to go with the fin again. Okay, so it created another one, but it put it in exactly the same spot. Let's rename this fin 2. Then let's move it over 25 centimeters in the Y direction. And for now, we'll just settle for 2 fins. You can add another one if you want, but it's the exact same process. So basically now we have our mesh. It has the surfboard and the fins with the mass distributed in the same way it really would be on the real system, instead of having the envelope and stuff. So now let's go ahead and run this simulation. Just a little bit of rotation. I want to see it fall onto the fins. Okay, there we go. And you can't grab now where there is no oof. Let's let it run. Okay. So we had our transparency for our second fin as 0, so it was invisible. Okay, and you can kind of move that around. You can grab onto it, zoom it. If you try and grab on where there's no, whoops, I kind of got it there. Okay, so this is one basic way how you can create something, decompose it into convex parts to kind of create your mesh. If a convex mesh is the whole piece, won't really work for you. And like you saw, it's really easy to do in SketchUp. It's just basically you're gonna select certain parts and save them out in separate files. It may involve cutting pieces off. For instance, with the locust, you could cut the antenna off and save those separately. So actually, for the locust, what I would probably do is just use a graphics mesh that has the antenna in it, and I would create a a separate mesh that I would use for the collision that does not have the antenna in it, and then when it creates a convex mesh, it'll create it on just the body part, so you have a minimized convex mesh that still have the graphics with the antenna in it. Okay, one last thing I'd like to demonstrate in this tutorial is how to use terrains. The terrain uses an RGB height map to set the height of each vertex of a mesh. It basically creates a mesh by looking at each pixel in an image and setting the height based on the intensity of the pixel. So white is the maximum height and black is the minimum height. So let's go and create a very simple height map and use it as a beach instead of using the plane that we had. You can do this in any image editing software. However, I'm going to use a program called GIMP. It's a free software tool that you can download from online. It's kind of the de facto standard for open source now. Okay, let's create a new image file. And let's set it to be 50 by 50. So remember, every single pixel in your image is going to be creating a new vertex for your mesh. So you don't want to have very high resolution on this, otherwise you're going to have a massive sized mesh with numerous polygons, and that's really going to slow your system down. So 50 by 50 is more than enough for what we're going to do right here. Okay, the next thing we want to do is to click the gradient tool, and then let's click it where it goes from white to black. And okay, so it's going to start out kind of white and then slowly move down to black. So what this should do is we should start out with something that's at the maximum height that slowly goes down to the minimum height. Okay, so let's go ahead and save this out as a JPEG. Okay, so once we have that, then what we want to do is to create a new structure. Add a root body. And we're going to select the terrain. So when that comes up, then what it asks you for is to specify a terrain file, which is our height map. So let's go ahead and click that. Then you can get a texture file, which we're going to use just the sand since we're making a beach. Then you have something where you can set up the segment width, segment length, and maximum height. So what this is the segment width and segment length specify the length in meters between two pixels. So in other words, it's 1 meter between pixel 1 and 2 in the width and the length right now. So in other words, if we had a 50 by 50, so we have 50 pixels in the width, and there's going to be 1 meter between each pixel. So our terrain is going to be 50 meters by 50 meters in dimension. The maximum height specifies the distance between the white pixels and the black pixels. So in other words, the distance between the minimum and maximum height values in the height map itself. So we're going to go ahead and go with the default settings for this. However, you can change these as you want. So for instance, let's go with a 10 meter. You can see it increases it right there. Or you could go with 2 meters. So you can change these even though you set them initially. It's, you know, there's not a huge, you're not stuck basically. Okay. So this added our terrain, and as you can see, we have a maximum height here. It goes down gradually into the minimum height. So what we want to do now is let's go ahead and focus on our parts. and kind of move stuff up so that it's sitting on the new terrain instead of the old plane. It's going to move it out towards the edge here. Okay. Okay. I think we got things kind of positioned. Let's go ahead and focus back on the tree. And let's see how our coconut fares. Okay, not quite how I wanted. Not bad. There, now it rolls down. It kind of goes for a while. Okay, next thing we want to do is so we have this plane. Actually, it looks like it's, no, it's a little high. No, it's not. Actually, you can see it right there. So basically, we made the plane come out This is going to be like the ocean floor. So our plane is out here. So if you didn't have a plane at all here, what would happen is that as soon as the coconut hit the edge of this train, it's going to fall off the edge of the earth. So by putting this plane down here, we can make it where the plane extends out to infinity. Even though the visible part is only right here, the plane actually is to infinity. So it will still continue to roll out even though it looks like it's on empty space. So let's go ahead and quickly make this to 200. 200. Okay. So it's actually kind of hard to see our... Okay, well, we won't play with that right now. If you adjust the lighting, you could probably get it where you can see the... or make it a little darker. There we go. That way you can at least see the difference between the two. Okay, so it rolls down the hill. Now, one of the last things I want to do, real quickly, is let's just go ahead and add a child body. And let's add a fluid plane. So basically, no beach would be complete without having an ocean. So we're going to add an ocean real fast. So let's go ahead and add that. Let's call it ocean. Let's move it up, part way up the beach. We're going to change this to white, and what we're going to do, well, first of all, let's change the size to... let's change the size back. I like it better the other way. Okay, let's go now and Google for seamless. There we are. Ocean texture seamless. Okay. So I applied it, but it completely stretched it there. Let's go ahead and do some segments. Okay. So let's focus on the coconut. Let's run our simulation. Bonk. Roll it down. Oh, and it goes right through the water. right onto the surface floor. And it eventually stops rolling. We got some pretty good momentum going there. Okay, so what happened? The main thing that happened was that our coconut is much more dense than the water. So let's change that back. Actually, let's change it to be a little bit less dense. 0.8. And try this again. Oh, and this time it bobs on the surface. Okay. Let's change the density again just a little bit. 7. Okay, so now it rides a little higher in the water. So we covered a lot in this tutorial, and I hope you found it useful. You can download the AnimatLab application for free at www.animatlab.com, and you can get a copy of this tutorial project in the Animat warehouse. Thank you.